Good afternoon. This session is Power Automatic Hasp-Type Spooling under DOS. My name is Victor L. Cushman. I'm with the EI DuPont Dina Moores and Company Incorporated in Wilmington, Delaware. I'm chairman of the session. Our speaker today is Mr. Larry A. Whitney, Field Systems Center representative from the IBM Corporation in Philadelphia, Pennsylvania. The cameras are here in the room because IBM is taking a movie of this presentation. Mr. Whitney will give us a formal presentation on the Power program. I will return then to give us with the Power program as used in DuPont. In 1967, we at DuPont recognized a problem with our 360 computer locations. In brief, our problem was first, that our 360 computers were not doing as much work as they were capable of and as much work as we desired. Second, many of our computer users, programmers, clerks, engineers, had to wait substantially long periods of time to receive their computer output. Third, we are in a growing business and expect continued growth, and therefore we needed an orderly, economical way to expand computer capacity and capability. And last, in order to achieve any of the other objectives, we needed a solution that was both practical to implement and practical to install. As it turned out, following extensive evaluation and feasibility tests in late 1967, we determined that an automatic disk spooling technique, such as is done by the Power program, was our best solution. It is designed to improve the throughput of 360 computers, Model 25 and up, operating under control of the disk operating system. It does this by using multiprogramming and multitasking techniques. Most of the credit for development of this program is due Mr. Larry Whitney. DuPont's part was to assist in the specification and documentation of the package and to provide sites where the product could be tested in the field. The rest of this session is oriented to give you information so that you can determine if the Power program can be of any benefit to your installations. I now give you Mr. Larry Whitney.
I want to sincerely thank you all for attending this session, and I hope you will gain some insight into DOS spooling as a result of our discussion. My discussion will be centered around the following three topics. Would you turn on the foil, please? We want to develop the concept of spooling for those people that have never had any contact with it. We want to see how the Power package supports spooling by reviewing what it does. And lastly, we want to review the benefits and costs of the system so you will have the facts in order to evaluate it for your own particular use. Our discussion this afternoon will not be talking about or mentioning any user files that are located on tape or disk in a normal fashion. We will only be talking about unit record devices in the categories of card readers, printers, and punches. Three characteristics of the system that are extremely important in our discussion are, number one, that all unit record I/O is under direct control of the batch program. The second is that both systems and programmer logical unit assignments may both point to the same physical device. The third characteristic that is important in today's operation is that the programmer, either through program statements in his object program or through DOS comments cards and pause cards, assists the operator in unit record setup. Now let's look at a simple spooling example Notice that we are only looking at printing in this example to keep it simple and straightforward. This foil reflects three very important characteristics and concepts of spooling. The first is that the print images, both job control and user lines, are stored out on disk. The batch execution is not bound by the speed of the printer. Second, the actual printing of the print images occurs at a different time. The disk is acting as a high-speed buffer between the batch execution and the spool partition. This is the vehicle that is actually used to separate the execution from the printing and make them independent of one another. The next foil exemplifies some of the benefits gained by changing today's operation to a spooling environment. The top portion shows 4 typical jobs in which job A is heavily print bound and jobs B, C, and D generate very little print output. The bottom half of the foil represents the same 4 jobs running under control of a spooling system. Recall the 2 concepts of spooling that we had just talked about, namely that the print images are being stored out on disk at execution time and that the printing is occurring at a different time from batch execution. Notice that job A originally had been heavily print bound and its execution time is significantly reduced. This is the goal of spooling. Once the backlog of a print job has been developed, our printer operates at maximum rated speeds. We will be able to handle a larger volume of printing within the same original period of time. To complete our discussion of spooling, it's important that we also bring in the other 2 unit record device types, card reading and card punching. And we now see in this example that batch execution is not bound by any unit record device. In summary, the spool's main goal is to increase the throughput of the batch partition by removing the direct tie that the batch has with any of its unit record devices. The next section that we will be discussing will indicate how Power provides this spooling support. Once the Power program has been initiated and executed in the foreground partition, it provides the functional capabilities of spooling as just outlined. Namely, the Power system provides for the independent operation of batch execution and unit record functions, and it is using disk as an intermediate high-speed buffer. No job stream changes are required in order to run the system, to run any program under Power. This statement applies to all job control, all IBM programs, and more important to you, all user programs. Hence, the systems and programmer logical unit assignments that are a part of your job control remain unchanged. DOS supervisors and job controls are not modified. User programs are not recoded, recompiled, or relink edited. Operation of the system is fully automatic in the sense that the operator does not have to use any special control cards or any special typewriter functions in order to make it work. The system issues, when necessary, printer and punch setup information. In the case of printing, printer forms change and carriage tape identification is provided. And in the case of punch, card identification and, very important, deck separation is provided. Restart of the Power system from either a normal or abnormal shutdown is completely supported. For operator ease, recovery is provided at a very predictable restart point. Job sequence can be controlled by the operator. He may determine the next job to be executed, the next job to be printed, and the next job to be punched. Multiple unit record I/O devices are supported by the package. This example shows 3 printers processing the print load that was generated by the background execution. We could have additional card readers, additional punches, for a total of 26 unit record devices being supported by the Power system. for jobs which generate large print volumes. Next foil, please. Tape may be used on a job basis as an intermediate device. For DOS users who operate 2 batches, the power spool system can expand to fully support their simultaneous operation. There is no need for any special programming or anything else in order to support 2 batch partitions, possibly with 1 card reader and 1 printer. If a user chooses to run a BTAM inquiry program while spooling, he can code it to run as a spool task operating in the same partition as a spool program. He may choose, but he does not have to choose to run it in another DOS partition. Minimum core for the power program starts at 12K. There have been systems installed and are operational that are using readers and writers at 12K, but they are very operationally oriented systems. Operational ease, number of readers and writers, and performance criteria all go into establishing what the actual core will be used over and above the 12K that is the basic minimum. At power spool systems generation time, the user can assemble his own job accounting routine within the power system to access the statistics that were created by the power program. A 2314 may also be declared at spool systems generation time to be the temporary storage device in place of a 2311. At least some portion of a disk is needed by spool. He may choose to share it, same volume with some user data files, but obviously the user's references to that data file have a very drastic effect on spool's performance. Some other features of the spool system fall into 2 categories. First category is primarily in the area of printing, in which you can call for multiple copies. You can call for the operator to restart the report after he has lined up the paper and he has printed 3 or 4 pages. The other category of a feature that's not indicated on this chart is in the area of operator commands that are available to him to analyze how the job queues and printer and punch queues are developing, what are the numbers of records in each of these jobs, and he has a way to manipulate them as indicated to alter the sequence of job execution, printing, and punching. Power system does provide the basic groundwork for some very promising features that users may tend to incorporate in their own system. Remote batch processing capability would allow the user to submit normal DOS batch jobs from some remote geographical site. Potential feature of storing DOS control cards on disk would remove the necessity to submit these control cards through the card reader each time the job was run. Not only is the power system designed to be flexible, but it was set up to be efficient during execution in the following ways. All spool disk I/O operations, both during execution and during reader-writer time, is blocked and buffered. The block size is a sysgen parameter. All spool disk space is under management of the power program in order to provide for the minimum amount of disk seeking. Unit record I/O overhead is kept to an absolute minimum by utilizing CCW chaining techniques. In addition, ASA look-ahead feature, which is a part of the output writers for the printer, also reduce the unit record I/O overhead. To continue with this session, let's now listen to Mr. Cushman's remarks concerning a user's experience of the power system.
Thank you. Just to restate briefly, the next foil recaps the problem that we at DuPont had when we began our investigation. Primarily, to improve the profitability of our computer installations by getting more work out of them. Also, to provide better service to computer users by reducing the turnaround time for job output. Since we are a growing business, we did need an orderly, economical way to expand capacity. And last, the solution had to be practical to operate and practical to install, or we could never achieve any of the other benefits. The next foil describes how power met our need, and we have confirmed in actual practice that power does meet our needs in the following categories. In the area of economics, we have been able to reduce our overtime computer rental. We have been able to avoid, or at least postpone, upgrading some of our installations to more powerful computers. And for our mix of work, we found there is no benefit in having high-speed printers, punches, and card readers. In the area of service to our computer users, we have noted a substantial improvement in job turnaround time when operating under the power system. In the area of flexibility for expanding computer capacity and capability, some of the things that provide us with useful options are we can move at some time in the future to a two-batch job operation at a fairly nominal cost when our load requires it. We could add a single printer or a single punch to encompass that load without changing the shop operation. Most interesting to me personally, I think, are the potential capabilities for doing remote job entry, the ability to support other devices such as plotters, paper tape readers, paper tape punches, and so forth, and the ability to insert a teleprocessing inquiry program as part of the power partition. The next foil shows the results of our evaluation considering the practicality of operation and installation. There are substantially no program changes. I hedge on this point because we did change about 2% of our programs, primarily 1,400 programs, which failed to skip to channel 1 at the beginning of each page. The ability to spool a job or not to spool a job with no changes is important because in our particular environment, we do switch in and out of spool depending on the workload. If the operator is currently running a group of jobs which are not being spooled, but has an urgent job come in which is capable of being spooled, he can insert that right in the card reader and run it just as a normal batch job with absolutely no changes. The excellent generality and completeness of the power program has helped to keep our installation periods short and extremely simple. Part of our implementation plan was to conduct field tests in actual operating locations to determine if anything needed to be changed in the power program. The changes are listed here. We modified power to allow channel 9 and channel 12 to be punched into the carriage tape so that the operator would not have to change carriage tapes when switching from spool operation to non-spool operation. We modified power to automatically reset the DOS line count to its standard value at the end of a job so that the number of lines per page requested by one program could not alter the number of lines per page required by any following programs. And last, since we are switching in and out of power throughout the day, we modified power to automatically start the printer and the punch program and allocate buffers to them. This saves 2 type-ins per initialization and help brings the spool program up fast. The next foil shows an approach we have found effective in installing the program once it has been thoroughly evaluated. Our approach has been to construct an installation team to assist each of our smaller remote locations with the installation of the power program. Before the installation team arrives at that location, the local organization generates their disk operating system and power programs. Of course, if they have 1401 programs around, they also generate the compatibility operating system. 3 software options are required in the DOS supervisor. There is no modification to the IBM supported program. 3 options are required. If you use COS, some options are required in it too, all of a standard nature. Power generation is very similar to compiling any other program in that it is in macro form, and you punch about 10 cards after selecting the options you want, and assemble it just as you would any other program. Also, before the installation team arrives, the location isolates jobs which they do not intend to spool, either because they use too much disk, use too much core storage, or perhaps have embedded operating procedures that make them inconvenient for spooling. Then the team arrives at the location and conducts orientation sessions for computer management, the systems and programming staff, and most importantly, we found, computer operations staff. The team then conducts on-the-job training for each crew of operators for about 2 shifts. We find that after 1 or 2 shifts, all our operators are able to handle power with no difficulties. I'm sure you're aware that very few software packages are ever installed in a location without requiring some change to an installation. Although it is not required by the power program, we found it economically beneficial to use one of its extra features, that is, the ability to get extra copy of printed and punched output. We found that some of our older, traditionally programmed systems were used to produce multiple copies of reports, and these were being obtained by rerunning the job. By using Power's facility for getting extra copies, we have saved computer operator labor and machine time then. The changes there are fairly nominal. The installation period, in our case, lasts from 3 to 5 days and goes fairly smoothly. The results that we have achieved are shown on the next slide. Several of our installations have been in operation for several months. The longest has been installed for 3 months. Several more of our installations will be installed in the coming months. What we have measured as a result of the installation is that we have achieved very substantial throughput increases. I won't give you a flat percentage of throughput increase because it is extremely dependent on the mix of jobs you run. Second, we found that many of our operators prefer to operate a spooling system rather than the regular DOS batch system. They find that they can exert more control as to scheduling jobs and keeping the setup time at a minimum, and feel they can do a better job. In our case, it is extremely practical to use and very flexible for expanding our computer capacity and capability. We also hope it can be of some benefit to you. Well, are there any questions now from the floor, either for myself or for Mr. Whitney? Yes.
Is there any more documentation in the area of internals of the system possibly available now?
So I've just finished the complete rough draft of a programmer's guide, which goes into all the internals of all the important queue processing techniques and manipulation of jobs and so forth. It is expected to be in a final form for resubmission to the Type 3 library probably within a month.
Core estimates or core requirements for individual type operations, either readers or writers for the printer or writers for the punch. Can you give us a handle on that?
The concept that was used in the implementation of core use for readers and writers is that basically of the 12 minimum K, about 8.5 or 8K of that is resident area of memory. The remaining portion is broken up into buffers, one for the program storage and either 1 or 2 for I/O usage. So if you take the default option that is used in the distribution, which is an 829 byte buffer, which gives you 4 blocks on a 2311 track, this gives you about 5 buffers left over in the 12K. And if you need more than 5 buffers for normal usage, then you probably go up the 2K increment to 14. That's how you could figure it out.
Can you give us any kind of feel as far as the range of amount of disk space required for both reading and writing, and maybe both?
The disk requirements vary with the quantity of printing or punching and reading you do, and the length of the maximum length of a given job. From direct experience, the first installation that was installed at DuPont used 1/4 of one 2311 disk pack and that encompassed 98% of their work. So since it reuses the disk over and over, the disk requirements are surprisingly small.
That was just output?
That was for print and punch output only. That's correct.
Well, what average size job did the quarter of a package suffice?
The vast majority of them run under 450 pages of output. I see that the session is about to end, so may I suggest we take one more question before we break. Then those of you who care to stay, I believe Mr. Whitney would be available to remain and answer your questions. One question, then we'll break.
I have a question about using power where you're already operating in a multi-programming environment. We have a production control system which is BTAM operating in the foreground. And I was wondering, could we use power for our background batch programs? If so, where would it be? Would it be in foreground 1, sharing BTAM, foreground 2, or background, or could it be used anywhere?
If you do not have a requirement for a second batch, you can use one foreground partition, whichever one you choose for your BTAM process control application. You can take the other one, whichever one is left over for the spool usage, and then the third partition is your background. Thank you very much.
Do you see any problems in future versions of DOS?
We anticipate no problems whatsoever, but we obviously can't promise it.
What's it written for now?
It's been run under Release 18.
How do you get the last page of a report printed and then decide whether or not you want to print the entire report?
Some jobs don't blend nicely into spooling because the punched output of job A is the input to job B. There's no easy way to split that control total.
Are there any problems with COBOL compilation?
No, in fact, one of our examples of where we got a 50% reduction on a 7-minute COBOL compilation on a Mod 65 went down to 3.5 minutes was with COBOL compile, in which they had about 4,000 lines of source code.
I assume that generating the power package is no substantial thing, is that right?
You pick them up, and then it's a 15-minute assembly on a Model 30. You have to use assembler F or whatever your size is, and then you have to link edit it.
Right. Assuming that I had at one time...
Like